talked about how helium, because its atomic number is smaller than nitrogen and oxygen, that actually becomes the reason that helium is going to float. So a helium balloon is going to float at the fair. And that idea correlates to weight. It also correlates to the scientific concept of density. And so we're going to talk about that a little bit more today as it pertains to these three layers of the Earth. In terms of density or weight actually can explain why those three layers of the Earth um, layer out the way that they do. We know that the crust is going to be at the very, very top, and part of the reason that the crust is going to be on the very top is because of the materials that make it up. The crust is going to be made up, 46% of it is going to be made up of oxygen, 20%, 27% is silicone, 8% iron, 5% calcium, and like 14% everything else. That being said, going back to the idea of the periodic table, oxygen is going to be a pretty light atom, and silicone as well, especially compared to something heavier like iron and calcium. So the fact that the fact that the crust is made up of such light atoms, relatively speaking, allows for it to essentially float on the more dense layers. Um, we know that with the crust, the mantle, and the core, the crust is going to be on top, and it kind of exists in what we're going to call plates, and we'll talk about that more in a different video. But these plates are going to literally float on other heavier, more dense layers. The layer that exists underneath the crust is going to be the mantle. The mantle is going to be relatively thick. It's about 1,800 miles deep. The crust is only a couple of miles, depending upon the region of the Earth. It could be anywhere from a couple hundred feet to maybe 5 to 10 miles, depending upon the region of the Earth that you're dealing with. But the mantle is going to be much thicker. It's going to be about 1,800 miles, and it's going to be made up of heavier elements. Magnesium and iron on the periodic table are going to be much heavier elements. And we're going to talk about this in the next video, but there's a term called convection that's actually going to drive how the mantle is going to be moving. That's right, the mantle underneath the crust is going to be moving. It's in constant motion, which we obviously don't see, therefore we don't think about. But it's that movement, that convection, that's going to cause the mantle to move, and therefore the crust to move once in a while. And that movement has the ability to induce earthquakes. The layer underneath the crust in the mantle is going to be the core. A couple of interesting facts about the core. The core is actually going to have two different layers. It's going to have an outer core and an inner core, but the core is going to be made up of iron. Iron, again, going back to the periodic table, iron is going to be a heavier element than magnesium or calcium or oxygen or any of those other elements that we talked about before. And because it's so heavy, it's going to literally sink to the middle of the earth. And that's part of why iron is going to make up the core. And something else that's interesting, we know that the Earth is spinning. We talked about this in our last unit. The Earth is rotating. One complete rotation happens in a day. It rotates once a day on its axis. But this is pretty crazy. There's a lot of different facts that are going to be here. The outer core is going to begin spinning, but the outer core is actually going to spin at a little bit of a different rate than the rest of the Earth. And scientists think that this core spinning a little bit differently, probably a little bit slower, would be my guess, that the core spinning more slowly than the rest of the Earth is actually going to be the reason that the Earth has a magnetic field associated with it, which is super cool to think about. What you guys need to be aware of is the idea that there are going to be three different layers: the crust, the mantle, and the core. And recognize that those three layers essentially sit on top of each other based upon how heavy they are. The heavier core is in the middle, and then the mantle, and then the crust is the lightest, and that's why the crust ends up